Problem number 3. This is a little different. I have 1, 2, 3, 4 terms. Let's go to our chart, our flow chart, to see what that means. Looking at my flow chart, I see that if I have 4 terms, I'm going to use grouping to factor. I'm going to show you how grouping works, and then I will show you how that fits into this equation for grouping right here. So I'm going to show you first and then kind of come back to the equation. This is actually kind of cool. It almost feels like a little bit of magic. All right, let's take a look. So the first thing that we do, we notice we don't have a GCF to factor out of the entire polynomial. So the first part of grouping is to group our polynomial into 2 smaller polynomials. So we're just going to bracket off the front half and the back half. And now what we want to do is look at each set of brackets that we just created. We want to find a GCF for each set of brackets. So we will look at x cubed plus 3x squared. And my GCF for that is x squared. What do I have left? X plus 3. Let's look at negative 7x and negative 21, and those have a negative 7 in common, and I will have x plus 3 left. Be careful here. We pulled a negative out as part of the common factor, so that means that this negative and this negative have become positive. Notice something special here. X plus 3 in parentheses, x plus 3 in parentheses. Those are alike. And this is the magic of grouping. If you are able to group as a method of factoring, that's always going to happen. If they are the same polynomial, the same binomial, but the signs are different, you probably forgot to factor out a negative. Go back and do that, and then you will have the same thing. Here's the way that grouping works. Grouping says this is like a like term. Okay, kind of like if we have 2x squared and 3x squared, we could combine like terms. This is a like part to this. So we can combine that, and we can combine the unlike parts of that like term, the x squared and the negative 7. And it looks like this: x squared minus 7, and then x plus 3. And that's what grouping is. From here, we would see if we could factor any further. X plus 3 is linear, it won't factor. And x squared minus 7, well, 7 is definitely not a perfect square or cube because it's prime, so we know that we can't factor this any further. Let's quickly go up to our actual equation for grouping, and I'll show you how what we just did fits it. So grouping says that if we have 2 like parts like this, this is equivalent to our x plus 3 that we had, and we have something else on the outside. Notice that these are not alike, an r and an s. In our case, we had an x squared here and a negative 7 here. But we can take r and s and put them together, group them together as the parts attached to a like term, basically. This whole a plus b thing is like a like term. All right, so that's how it works. If you want to prove to yourself that it actually works, because I know some of you are going, wow, that's kind of cool, but how? Go ahead and work your way backwards. Take x squared minus 7 and multiply it by x plus 3. Use our multiplication skills that we learned back earlier in the chapter. And once you do that, you should be able to work your way back to our original polynomial. That's the way that grouping will work. It's a factoring method, and factors should always be able to get back to our original polynomial. I would like for you to try problem number 4 on your own. Notice that we have 4 terms, just like we did in number 3, so we know that we're going to be using grouping. Once you're finished with grouping, take a look and see if you can factor anything else. Come back here and see how you did. All right, let's take a look at this problem. So what you should have done is grouped, just like we did in the problem before. I'm going to group the first two things and the last two things. And for the first two terms, m to the fourth and negative 2m to the third, I'm going to factor out an m to the third and be left with an m minus 2. Whenever I factor out the greatest common factor for negative 27 and 54, remember I want to bring that negative out to the front. I have seen a common mistake of thinking that the common factor here is 9. And while that is a common factor, it's not the greatest common factor because 27 actually divides into 54. So be sure that you're pulling out the greatest common factor. And when you pull out negative 27, you should end up with another m minus 2. Be super careful here. We've taken out a negative 27, and so this becomes a negative sign. Remember that you should be able to do this multiplication, this distribution, and get back to what you had. I have negative 27 times m, negative 27m. Negative 27 times negative 2 will give me that positive 54 that I started with. Once I factor out my GCF, I combine the m cubed and the negative 27 into one term, and then I do m minus 2. The common thing that they had, we're kind of combining like terms here, m minus 2 goes in the second parentheses. M minus 2 is linear. It's going to come along for the ride for the rest of the time. However, I notice that I have an m cubed minus 27. By now, you should be starting to recognize this is two terms. It's subtraction. They are both perfect cubes. I'm going to use difference of two cubes to factor this one more time. I'll end up with m minus 3 and m squared plus 3m plus 9. Don't forget, this m minus 2 is now just coming along for the ride. So please don't forget to write that as part of your final answer. We cannot factor any more than this because remember, once we do a difference or sum of two cubes, this is an unfactorable quadratic that we have left. We will not be able to come up with factors of 9 that add to be a 3.